All right, the last thing we're going to look at is interest. And interest is a common percent problem that dogs us all the time. Interest is used in banking, and there's two types of interest. So, interest is a charge on money borrowed. So, if you put money into your savings, the bank pays interest because they borrow that money and they lend it to other people. So you get interest into your savings because your savings account is lending the bank money. Now, if you take out a loan or use a credit card, you get charged interest because you borrowed money. And so that's their way of making a profit off of borrowing money. You have to pay back more than you took out, and the interest is the more that you pay back. And the money borrowed is called the principal. And interest is done as a rate, so we'll have an interest rate. And that's usually done per year. It's per some period of time, so it's a percent per time, and usually it's per year. And so we have a couple different ways of computing interest. The first is simple interest. And so simple interest is the interest is going to equal the principal times the rate times how much time has passed. And so generally this is per year. And so time has to be measured in years. So, for example, the simple interest on $500 at an interest rate of at a rate of 12%. Again, it's usually understood to be per year, for 2 years. So the interest is going to be the principal, which is $500, times the rate, which is 12%. Now again, I'm going to convert the percent to a decimal by moving 2 decimal places to the left, times the time, which is 2 years. And so if I run to my calculator, I get $60. What this means is if I take out a $500 loan for 2 years at a 12% rate, at the end of those 2 years, I will have paid back $560. Let's say you borrow $1,500 on a credit card, which has a 20% rate, which is actually low for credit cards. Credit cards are usually 15 to 20% above the federal interest rate. So usually they're much higher than this. And paid it in 9 months. And so here, the paying in 9 months is going to be the odd part. So what we'll look at is the rate, or time, or the principal times the rate times the time. But time, well, there are 12 months in the year. So the time is 9/12 of the year. So $1,500 times, and I'm going to do the same trick I do with percentages. I'm going to move the decimal 2 to the left, so this is 0.2 times 9/12. And I guess I can reduce 9/12. 1500 times 0.2 times 3/4. Well, I'll run to my calculator, and this gives me $225. So the credit card, $1,500 for 9 months on the credit card. Well, if I add those together, that's $1,725. So the larger the interest rate, the quicker this adds up. And so the total amount is the principal plus the interest rate. Now, another way we do interest is we can compound it. Now, what happens when you get a big loan on like a car or a house, they compound the interest rate. So what it does is they have compounding periods. So let's say I borrow the money for 5 years. But whatever the terms are, so many time periods, 1, 2, they'll add what's owed back in to the remaining amount. They'll recompound it. So instead of waiting till the 5 years to calculate it, let's say they calculate the interest at these intervals. 15. So here we're doing it every 3 months. They'll compound the interest. Or we can compound it annually. Let's look at what this looks like. So the amount, and this has a crazy looking formula, the amount of interest is the principal times 1 plus the interest rate divided by how many times per year it's compounded, raised to the power of how many times per year times time. So, for example, if it's compounded annually equals 1 is annually. We compound it once a year. If it's compounded monthly, well, that's compounded 12 times a year. If it's compounded weekly, that's 52 times a year. So let's look at an annual compounded interest. And this should always encourage you to pay back your loans more quickly. So for its annual, so n equals 1, we're going to take out $1,800 at 2%. And we're going to have it for 3 years. So n equals 1, the principal is $1,800, the rate is, again, my trick of moving the decimal place, 0.02, and time will be 3 years. Try to keep this centered up here. So the amount will be 1,800 times 1 plus 0.02 divided by 1 times 3. And here the calculator is really going to help. If you use the parentheses on your calculator and parenthesis your exponent, this will spit out the answer nicely. But if I work this out here, this is 1,800 times 1.02, and I work this out to the third. And so I put all that on the calculator and get $1,910.17. And that's the total amount paid back in those 3 years. Now we can compound daily. So let's say we compound interest daily. So We invest $5,500 at 6.25%. We're investing this, and the interest is compounded daily. So every day we get money back into the account. And we want to know 5 years later, how much did this investment, how much money could we take out of this investment? So we notice daily there are 365 days in a year. So N is going to be 365. My principal is the $5,500 I've invested. And my rate is the percentage, but I'm going to do the trick of moving the decimal place over. 2 to the left, 0.0625. I'm going to have it for 5 years. So the total amount I'll have in this account at the end of 5 years is the principal times 1 plus r over n times n times t, right, to the power of n times t. So for this, the principal is 5,500 times 1 plus 0.0625 divided by 365 to the power of 365 times 5. I can't do any of this without a calculator. So I go into my calculator and I type all of this in. I use my parenthesis key and I use my up arrow key. Right? So on most calculators, this would look like this. 5500, the times key, parenthesis, 1 plus 0.625 divided by 365, parenthesis, up arrow, parenthesis, 365 times 5. And that's usually how you type in on most scientific calculators for that. But I looked at my calculator, and at the end of this time period, I will have $7,517.41. Get used to using this formula. It's a very important formula, and it lends its way into some other things in mathematics. This idea of adding back a proportion comes out very naturally, and so this pattern will pop up again. But this is how we do interest on investments and on loans. And this finishes Module 7.